Hello everyone, welcome to the discussions of the past year questions. In this video, we shall take a look at the further mechanics, May-June 2023, paper 31. Let's take a look at the questions. Number 1. One end of a light elastic string of natural length A and modulus of elasticity 3 mg is attached to a fixed point O. The other end of the string is attached to a particle P of mass m. The string hangs with P vertically below O. The particle P is pulled vertically downward so that the extension of the string is 2A. The particle P is then released from rest. Okay, so this is the situations. We are having a fixed point O. This is the original length, A. Then you pull down with the extensions of 2A. And then you release it. Okay, so this is D. Then find the speed of the P when it's at the 3/4A below the O. Okay, so what you need to do is that after you release, you are actually located somewhere here, 3/4A. Okay, so you're moving from here, going up here. So what is your total height? Your total height is actually 3A minus the 3/4A. This one is the 9/4A. Okay. Then you can see that over here you have tension, but over here you have no tension. Okay, because it's already less than the original length, so it will be no tension over here. So what you need to do here is conservations of energy. You have a GPE gain plus the KE gain is equals to the EPE loss. Okay, so what is the formula for the GPE? Formula for GPE is a mgh. H just now we have calculated is a 9/4A. KE gain is a half m of the v square minus a u square. U is a 0. Okay, you are starting from rest. This is the v. Then EPE gain will be the lambda. Okay, the lambda is 3 mg. Then the extension is 2A. You used up all your elastic potential energy. Okay, so this one is divided by 2A. So cancel all the m. You get 9/4 GA plus the half V square is equals to the 6 GA. So your V square, just use your calculator. 6 GA minus 9/4 GA. Okay. So then you will get this one as the 15/2 GA. They want to find V, just square root it. So your answer will be 15/2 GA. That is the answer for the part A. Now we move to the part B. The initial accelerations of B when it's released from rest. Okay, so you release from rest. I mean here, this is a, this is a 2A, and you release from rest. So when you release from rest, and if you resolve the forces vertically, you have the T minus the mg equals to the ma. Okay. So to avoid misunderstanding, and because the a that we have here, this a is accelerations, and we have a here is the length. So to avoid misunderstanding, this a, I will use x double dot in front, on top. Okay. So over here, T will be the lambda x over L. Your lambda is 3 mg. X is a 2A. L is a minus a mg. So simplify and cancel it. You will get this one as the 5G. Okay, so you are going positive. Okay, so this one is positive. That means your acceleration positive. That means you're going upward. Okay, so that will be the answer for the question number 1B. Okay, now we look at question number 2. You have a diagram here. A particle P of mass m is moving with a speed u and a fixed smooth horizontal surface. On the smooth horizontal surface, it collides at an angle alpha with the fixed smooth vertical barrier. After the collision, P move at an angle theta with the barrier where tangent theta is equals to half. C diagram. So this is the theta, this is the alpha. Okay. Then after that, the question mentioned that the coefficients of restitution between the P and the barrier is E, and the particle loses 20% of the Ke as the result of the collision. Okay, so we have, this is before, this is after. Okay, so for before and after, usually we will write it out like this. Before, this is the U. Then this is alpha, so therefore this is alpha. Then after will be here. We are going to resolve it vertically and horizontally. So this is a theta. So if you resolve it vertically, that means you are focusing on this path and this. So before and after, by right, their motion supposed to be the same. Okay, perpendicular to the collision. So over here, your u cos alpha is supposed to be equal to the v cos theta. Okay, but before that, before we continue, actually the question mentioned to us that we have a tangent theta is equals to half. So we can actually from here, tangent theta equal to half, we can draw a triangle here. This is a 1, this is a 2, this will be a square root of 5 using Pythagoras theorem. So from here, we can actually say that the v cos alpha is u cos alpha is equal to v cos theta is equals to the 2 over 5 cos alpha, cos theta. Okay, then if you go horizontally with the Newton experimental law or the law of restitution, then you are having the E is equals to the V divided by U. Okay, is a horizontal. This one is involving the horizontal motion, which is here and here, before and after. So before is go this way, after it go this way. Okay, then this one is supposed to be V sine theta. This one is U sine alpha. Okay. Now, we also already know that the U sine alpha, EU sine alpha is equal to the V sine theta. And since the sine theta from the triangle over here, sine theta is a 1 over sec 5, you can write it as a 1 over sec 5 V. Okay, so this will be the equation that we have. It's not the V here. There's supposed to be a V here. Okay, so this one, this is supposed to be the situations. Okay, maybe I write it down properly. So this one, you get U cos alpha is equals to the 2 over sec 5 V. Okay, then now we can make use of this information. they say that the particle loses the Ke as the result of the collision. Okay, so we know that the Ke loss is the 20% of the kinetic energy. The kinetic energy is referring to the original kinetic energy, half mu square. Okay, so Ke loss is actually half m u square minus a v square. This one, if you simplify it, you will get this one as a 1/10 mu square. Then you can cancel the m. You just multiply it together. You have a 5u square minus a 5v square equal to the u square. Okay, so over here you will get that the v square is actually 4/5 u square. Okay, v square is a 4/5 u square. So from this relationship, okay, we actually can make the v become 5/2 u cos alpha. So I will call this equation 1. I will call this equation 2. And I will call this equation 3. So 1 into 3, you will be having 5/4 u square cos square alpha equal to 4/5 u square. So the u square can be cancelled off. You have a cos square alpha is equals to the 16/25. Since they only want the they want the E. Okay, so over here we can just write our cos alpha is equals to the 4/5. It's supposed to be positive, acute angle, because you can see that the alpha that they give you, the diagram, the alpha is acute angle. So your cos alpha is supposed to be positive. Okay, so for the energy considerations, we have found the cos alpha. Okay, so if we have found cos alpha is a 4/5, you can build a small triangle here. So this is a 4, this is a 5, that means this is a 3. Okay, so now we consider these situations. Taking the alpha, we already have cos alpha. We have a sin alpha. Actually, we want to find the E. So to find the E, let's take this equation number 2 divided by equation number 1. Okay, just take the equation number 2 divided by equation number 1. So to show it over here, 2 divide 1, it will be EU sin alpha divided by the U cos alpha. Well, I suppose to use this better. Okay, suppose to use U cos alpha equals to the 2/5V. Two over 5V. Then just now the numerator one is a 1/5V. Cancel the V, cancel the U. You have a E is equals to the half cotangent alpha. Okay, so cotangent alpha, you can refer here. Cotangent is actually 4/3. So your E will be 2/3. Just like that. Done for this question number 2. Okay, so now we move on over here. Okay, now we take a look at question number 3. A particle P of mass M is attached to one end of a line in extensible string of length A. The other end of the string is attached to a fixed point O. The particle P is held at the point A where OA makes an angle theta with the downward vertical through O. With the string tau, the particle P is projected perpendicular to OA and upward directions with the speed U. Then it starts to move along a circular path in the vertical plane. The string goes slack when the B is at a B, where AOB is 90 degree, and the speed of P is square root of 4 over 5 AG. So the diagram will look something like this. This is the point O. So you have a string. There will be a tension here. Then this is the point A. You are having a mass is a mg. This angle is theta to the downward vertical. So now after that, the next motion is that you are at here. This is a 90 degree. So if this is a 90 degree, then this one supposed to be a theta. Okay, or you can say that this one is 90 degree minus a theta. Okay, up to you to decide. So over here, usually we just call this part as a theta will do. Then you have a tension here. So this tension later we're going to make it become 0 because it's slack. So at the moment we assume that you have another tension here, tension A, tension B. Then this is your low positions, your position B. You're still having mg here, but the speed that you have, the speed that we have here is a u. The speed that I have here is square root of 4 over 5 GA. So this is what they give you. Okay, so this one is a vertical circular motion. Then I need to find psi theta. I will resolve the forces at B. I resolve the forces to the center. Then I get TB plus the mg. Now this is a theta. Mg psi theta is equals to the centripetal force. M V square over centripetal force, mv square over the A. Okay, so your TB is a 0. That means that my mg sine theta is equal to the 4 over 5 mg. Then mg and mg cancel. Therefore, sine theta is equal to 4 over 5. Okay, done. Then part B. In terms of in terms of m and g, the tension in the string when the B is at A. Okay. So when you are at A, okay, so we're still considering the path that you are moving vertically from A to B. From the center, from the coefficients of, from the conservations of energy, we have the GPE gain, but the KE is lost. Okay. So now, how are we going to build the formula? GBE gain is a MGH. The H will be referring as the H here. So the H is actually A cos theta plus the A sin theta. This is the H. KE loss, it will be half M, the U square minus the V square. Okay, so we can cancel the M. We have a 2GA cos theta from here. This is a 4. This is a 5. This is a 3. Cos theta is 3 over 5. Sin theta is a 4 over 5. Okay. Your U square. What is your U? According to the questions, we do not have the U. We only have the V. The V is this is the V. Okay. 4 over 5 AG. So this one is a U square minus a 4 over 5 AG. Okay. So join them together. 14GA over 5 plus 8 over 5 GA is equal to the half. Oh, this one is not an 8. This one is a 2 over 5. This one is a half U square. So your U square, just need to arrange everything accordingly. Press a calculator. you get this as the 2/5. (32). 2/5. 7/5. Oh, I make a mistake. There's not supposed to have a half here because the half, I already multiply it to here. So there's not supposed to have a half anymore. Okay, the half. So the 2, this half, I already multiply it over here. So there's not supposed to have a half anymore. Okay. So this is what we have. This is what we're having. Then this one, it will be, this one is a plus of 4. So therefore your u square will be the 18/5 GA, or you can write the u as a square root of the 18/5 GA. That is what I need for the conservations of energy. So now I want to find the tension at A. So at A, you just need to resolve the tension towards the center. Then you will get that the dA minus the mg cos theta is equal to the m u square over A. Okay. So this is, we are just focusing on this part. Just focusing on this part. Okay, just focusing on this part. Oops. Okay. Just focusing on this part. So if you resolve the forces, you get dA minus the mg cos theta equal to the mu square A. So the u square, we can just make use of the u square to here to get the answer. So you can have this as the TA is equals to the mu square plus the mg cos theta. Cos theta from this triangle here, cos theta is a 3/5 mg. So simplify it, you get 21/5 mg. That will be your tension of P at A. Okay, so done for this part. An object is formed from a solid hemisphere of radius 2a and a solid cylinder. Okay, so this is the hemisphere. This is the cylinder. The radius for the cylinder hemisphere is 2a, and the radius for the cylinder is a. The height for the cylinder is d. The hemisphere and the cylinder are made from the same material. The cylinder is attached to the plane face of the hemisphere. The line OC forms a diameter. OC is a diameter of the base of the cylinder, where C is the center of the plane face of the hemisphere and O is common to both circumference. See the diagram. Relative to the axis through O, parallel and perpendicular to OC as shown, the center of the mass object is bar X and bar Y. Okay, so these questions, the first part of the question is actually they are looking for the center of the mass for this combined solid. So what you need to do over here is we just build the table. Okay, just build the table. So we have a solid of cylinder. We have a solid for the hemisphere. So this is the combined solid. And since they are using the same material, so we don't need to use the mass. Okay, because they have the same density, we can just use the volume will do. So the volume for the cylinder will be the pi a square d. The volume for the hemisphere will be a 2/3 pi over 2a cubed. But this one, if you, I think I will expand it. So if I expand it, I will get this one as the 16 over 3 by a cube. So I join together, combine them together. I factorize the by a square. Okay, I factorize the by a square out. Then this one, it will be d plus the 16 over 3. 16 over 3a. Then we need to find the center of the mass from the y-axis. And also we want to find the center of the mass from the x-axis. This will give you the combined solid. The center of the mass will be bar x and bar y over here. For the cylinder, okay, actually cylinder, we know that the center of the mass is at the center. So from the y-axis, it will be only a. From the x-axis, it will be half of the d. So this one will be a and half d. Then for the hemisphere, you just need to refer from the formula booklet MF19. It actually have shown that it's a 3 over 8 from the radius, center of the radius, center of the circle, center of the hemisphere. So this one it will be 3 over 4a. So this one will be 2a and 3 over 4a. Okay, so but this is actually below, okay, because you can see that this is my horizontal axis, and this coordinate, since we're talking about the coordinate and is below the horizontal axis, so this will be a negative. Okay, so now let's find the moment about the y-axis. Then you get a pi a squared d multiplied by a plus the 16 over 3 pi a cube multiplied by 2a is equal to the pi a squared d plus 16a over 3 bar x. So the pi a square cancel. This one is a, remain a over here. So you have a 3ad plus the 32 by a square divided, no more pi, okay, 32a square only, divide 3 is equal to the 3d plus the 16a over 3 bar x. Okay, so now you can cancel the 3. So therefore your bar x will be 32a square plus the 3ad divided by 16a plus the 3d as shown as the question stated. Okay, so this one done for the bar x. So now we want to go for the bar y. So in order to go for the bar y, just take the moment. Similarly, just take the moment about the x-axis. So you just need to multiply volume, multiply with this. Okay. So what you need to do now, just to expand them, you get a pi a square half d square. Okay. Then minus the 16 over 3 by a cube and 3 over 4a. By right, supposed to be a negative. Okay, maybe we should write negative here. So this one we write plus, but this one we write negative 3 over 4a. This will be clearer. Then this one will be pi a square 3d plus the 16a over 3 bar y. So pi a square cancel. This one still have a. Then you get this as the this, if you cancel it, you will get this one as a half b squared minus the 4a squared minus the 4a squared is equal to the 3d plus the 16a over 3 bar y. Okay, so just combine together, simplify it. So at the end, you will get this one as the 3d squared minus the 24a squared divided by 2 of 3d plus the 16a. That will be the answer for the bar y. Okay, so that will be the answer for the part A as well. So we have done part A. Now we go for part B. Part B say that the object is placed on a rough plane, which is inclined at the horizontal and at an angle theta, where the sine theta is equal to the 1/6. The object is in equilibrium with CO horizontal, where the CO lies in a vertical plane through a line of a greater slope. Okay, so when you have an inclined plane like this, where the sine theta is equal to 1/6, then your object will be either put it like this. If you want to remain horizontal, the CO, okay, this is the C, this is the O, or there's another possibility. Another possibility is this. This is the C, this is the O, okay? So over here, actually, this one is not possible because you can see that if you find the center of the mass may be somewhere here, and it's going down like this. Okay, so it's not able to remain horizontal. It's not able to remain horizontal. So the only possibility that the CO to be horizontal then means that this must be the correct diagram. Okay, this must be the correct diagram. So now let me draw this diagram properly, bigger and clearer, so that we can see how to find, how to solve the question. So we have an object. Okay, I think I need bigger diagram. Let me erase it. Let me draw it like this. Draw the hemisphere first. So you have, okay, put it like this. This is the C, this is the O, and this is the cylinder. Okay, so you can see that this is a tangent. This is the tangent to the hemisphere. So when it's a tangent to the hemisphere, then the normal contact force will pass through the center of the hemisphere. Okay, then this is your center of the mass. Okay, so center of the mass, it will be exactly, it must pass through exactly the contact point because you have only one contact point. The contact surface have only one point only. So your W must be okay. Wait for a while. So this is your center of the mass. It will be passed through here. This will be your W. This is a tangent. And they mentioned this is rough. They mentioned that the surface is rough. So if the surface is rough, then the frictional force will go this way. Frictional force will go this way. Okay, so you can see that these three forces, the R, the W, the FR, they actually pass through a point. That point is a contact point. Okay, so, but we are not really interested on the W and the FR and the R as well. We just want to know what is the angle. We just want to know what is the D in terms of A. Okay, so from here, we know that this is a theta. Then this is a 90 degree because it's tangent, right? So that means this will be a theta. That means this will be a theta. Okay, this is the bar X. Then this will be the 2A minus the bar X. This is the A. Okay, So if you focus on this triangle, and I take this triangle out, so this is the theta, this is the A, this is the 2A minus bar X, then you have the sine theta is equal to the 2A minus a bar X divided by 2A. The radius is 2A, huh? Okay, so this is a 2A. So sine theta is 1 over 6. So that means 1 over 6 is equal to the 2A minus bar X divided by 2A. So continue over here, you get this one as the 2A minus a bar X is equals to the 1 over 3A. So your bar X is actually 5 over 3A. Your bar X is a 5 over 3A. Okay, but we want to find D in terms of A. So to find D in terms of A, we need to change your bar X. Just now from the part A, we already have the bar X as the 3A, the 2A square plus the 3AD from the part A result divided by the 16A plus 3D is equal to the 5 over 3A. So what you need to do now is just to do the cross multiplications. You have this as the 96A square plus the 9AD is equal to the 8DA square plus the 15AD. Then you get this one as a 16A square minus 16A square minus a 6AD equal to 0. Factorize the 2 and A out. Factorize the 2A out. Then you have a minus a 3D equal to 0. Then your A is equal to 0 and your D is equal to the 8 over 3A. This one ignore. Because if the A is a 0, then you have no radius at all. Okay, so that will be your answer for these questions. Okay, so this will be the answer for this question number 4. Okay, so now we take a look at question number 5. A light elastic string of natural length A and modulus of elasticity lambda mg has one end attached to a fixed point O on a smooth horizontal surface. When the particle of mass m is attached to the free end of this string, it moves with a speed v. Then the radius is x. Move with the horizontal circle with the radius x. When instead the particle of mass 2m attached to the free end of the string, the particle moves with a speed of half v with the horizontal circle with the center O and the radius is 3 over 4x. Find x in terms of A. So we just do one by one. When the mass is a m, then your tension number 1, it will be the centripetal force. It will be mv squared over the r. Your D1 is a lambda mg. The extension is x minus a divided by a is equals to the m of the v squared divided by the radius. The radius is x. Okay, so we can cancel this. Then cross multiply, you get lambda gx x minus a is equal to the av squared. That is equation number 1. Then when the mass is equals to 2m, so you have a T2 equals to the 2m. The speed now has decreased to become half v only. Then the radius is 3 over 4x. So the lambda number 2 is still a lambda mg. 3 over 4x minus the a divided by the a. So this one it will be m v squared over the 3 over 4x. So the m also can be cancelled. So you have 3 over 4 lambda gx 3 over 4x minus a is equals to the AB squared. Okay, so this is what we have. So you can see that the equation 1 and equation 2, all of them have AB squared. So what you need to do, just take the equation 1 equal to equation 2, then you get the lambda gx x minus a is equals to the 3 over 4 lambda gx 3 over 4x minus a. So lambda gx and lambda gx can be cancelled. X cannot be 0 because f is 0, then it will have no radius at all. So over here you have x minus a is equal to the 9 over 16x minus the 3 over 4a. So over here, 9 over 16. Wait for a while. This is 7 over 16 x is equal to 1 over 4 a. Oh, sorry, I make a mistake. This one just now, when I do the expansion over here, this one is wrong. This is the 1 over 2v. So this one is actually supposed to be as a mistake here. Okay. So let erase it. My apologies. Okay, so for these questions, you have 1 over 4 v squared times 2. So 2 times 1 over 4 v squared is actually half. It's actually half. So this one is actually mv squared half. Then you get this one as a 3 over 2x. You're supposed to get this. Then if you cancel the m and you do the cross multiplications, you will get this one as a 3 over 2 lambda gx 3 over 4x minus a is equal to the ab squared. Now this is the equation number 2. If you let equation 1 equal to equation 2, is equals to the 3 over 2 lambda gx 3 over 4x minus a. Lambda gx and lambda gx cancel. Then you get this one as a 9 over 8x minus a 3 over 2a. Then you get this as the half a is equals to the 1 over 8x. So your x is equal to the 4a. That is how you get the answer for this question number 5. Okay. So now we move on to the question number 5, B. So now when the V is equal to the square root of half AG, so we want to find the lambda. You can replace it into the equation 1 or equation 2. That is totally up to us. So I will put them into the equation 1. It will be lambda gx x minus a is equal to the ab squared. But just now in the part A, we already know that the x is a 4a. So if we put this inside, you have a lambda g 4a minus a equal to the a v squared. Then you can get this one as the 12 lambda g a squared is equal to the 12 g a squared. 12g a squared, 12g a squared cancel. You have a lambda equal to 1. Done. That will be the answer for the number 5B. Okay, now we take a look at question number 6. A particle P moving in a straight line has displacement x meter from a fixed point O on the line and velocity v meter per second at time t second. The accelerations of P in meter per second square is given by 6v square root of v plus 9. When t equal to 0, x equal to 2, and v equal to 72. Find an expressions v in terms of x. So for these questions, your accelerations is 6v square root of v plus 9. So since they want v in terms of x, we just need to change our acceleration to become v dv dx equal to the 6v square root of v plus 9. Okay, so the v can be cancelled. Then you get this as the 1 over the square root of v plus 9 dv is equal to the 6 dx. We use separable variable to solve it. So over here, if you integrate this part, you can actually get this one as a v plus 9, 2 square root of v plus 9. Okay, so this one quite straightforward. Then you have a 6x plus c. Then make use of this information. Just need to use x and v. When the x is a 2, v is a 72. When x is equal to 2, v is 72. So that means you have a 81, 12. So your c will be a 6. Okay. So now replace the c equal to 6 inside these equations. Square both sides. You can get 4v plus 9 is equal to the 36x squared plus the 24x plus the 36. So you can get v is equals to the divide 4. You get 9x squared. Divide 4, you have a 6x. 9 minus 9. Okay. So over here, 6x. Oh, this one I make a mistake for the expansion. This one's supposed to be 72. 72 divided 4 is 18. So your v will be 9x squared plus 18x. That will be the answer for the part A, v in terms of x. Now we move on to the number 6b. Find the expression in terms of t. So for these questions, just copy down the result that we have earlier. This one is a 9x squared plus 18x. Okay, so now since I want to find the displacement x in terms of t, I need to change this to become dx dt equals to the 9x x plus 2. Factorize it. So over here, you can see that just apply the separable variables. You have something like this. Now, over here, we were going to use partial fraction to do it. Okay, so if we use partial fraction to do it, actually, we can just direct split them. This is the half. This is the 90 plus c. Okay, so just in case you have forgotten how to do the partial fractions, we just do a quick revisions over here. 1 over the x plus 2, you make it become a over x plus b over the x plus 2. So this one you're supposed to get a multiplied by x plus 2, then bx. When x equal to 0, your a is equal to half. So when your x is equal to -2, your b is a -half. This is how you do the partial fractions. But in exam, actually, you can just direct. If you can do it directly, just go ahead, split it directly. So this is optional. This one is optional. If you refer to mark scheme, actually mark scheme, they never show how to do the separable, how to do the partial fractions. So over here, if you integrate, you get the half ln modulus x minus the ln modulus of x plus 2. equals to the 90 plus C. So again, go back to the questions. The question telling you that when T is equal to 0, your X is a 2. So you will have half ln 2 minus a ln 4 equal to 0 plus C. So the C is actually half ln half. This one join together, you get a ln half. Okay, so it's a half ln half. Actually, half ln half is a negative value. But when we write over here, you cannot see the negative value. So from here, back to these equations, I will be getting this. Join together is equal to the 90 plus half ln half. So join together again, you have a ln, join together again. So straight away, 2x over the x plus 2 equal to 90. Then your 2x over the x plus 2 is equal to e to the power of 18t. Okay? Then just multiply it to the other side. Together. Join together. Then you can have x in terms of t. That will be your answer. Okay, this is the answer already. The question didn't mention any particular form, so actually you just need to leave it like this is good enough. But however, if you solve a lot of mechanic questions, further mechanic questions, usually they like to ask the questions that what happened when the t is approaching to infinity. Okay, so if you leave into this form, you're not able to get the answer when the t approaching to infinity. So usually for this kind of expression, usually we want to make it the e to the power of 18t. Usually we try to make it become this. That means I divide everyone by e power 18t. I divide everyone by e power 18t. So therefore, usually we will take this as the answer. Now to highlight to you that this answer is not wrong. Okay, actually both of the answer can be accepted. Okay, both of the answer can be accepted. This answer is okay, this answer is okay. But it's just that if you talk about preferences, usually we prefer the second one because we want the e to the power of the power of e to be a negative value. Okay, so this will be the answer for the number B. Seven, at time t second, a particle P is projected with a speed 40 meter per second and an angle theta above the horizontal from the point on a horizontal plane and move freely under gravity. The greatest height achieved by P during the flight is h meter and the corresponding time is t second. Okay, so they want to obtain an expression for h and t in terms of theta. So this one, since it's involving time, we will have a horizontal and vertical displacement. Horizontal displacement will be x is equal to the u cos theta t. Then for vertical, it will be y is equal to the 40 sin theta t minus the half g t square. Okay, then I need to find maximum height, greatest height. So from here I find the dy dt. I get 40 sin theta minus the gt. Then at the t equal to t, your dy dt is equal to 0. That means 0 is equal to the 40 sin theta minus the gt. Then the t is actually equals to the 40 sin theta over g. Since the question mentioned only in terms of theta, the g, I will make it become 10. Then I will get this as my t. Okay. Then now I want to find the h. So to find the h, I actually just need to use this. replace the time t equal to the 4 sine theta, then you can get the h. Okay. So I will do it over here. Just say that when the t is equal to the 4 sine theta, then this will be a h. Your y is a h. So h is equal to the 40 sine theta, 4 sine theta, minus the, since I changed the g become 10 already, yeah. So this one, it will be 5t square. So over here you get 160 minus the 80. Okay, so you get 80 sine square theta. That is your h in terms of theta. Done for the 7a. Okay, now we go for part B. During the time t equal to t and t equal to 3, so you have two different time. The height in descends in the distance of half of the h. So when t is equal to t, this is actually from the result that we have earlier. The height is actually 40 sine square theta. Sorry, 80 sine square theta. This is what we have earlier. Just copy down only. Then when t is equal to 3, so I need to change this to become 3. So your height, I call this one height number 2. Okay, this is the height number 1. This is the height number 1. Okay, so over here, it will be 120 sine theta minus the 5 times 3 square. So you get 45. 120 sine theta minus a 45. Then the height minus a h2 is equals to 1 over 4h. Okay. So that means your h2 or my h2 is actually 3 over 4h. And since the h is a 80 sine square, we can write this one as a 80 sine square. Then you get this one as a 60 sine square theta. That is my h2. Okay, so you can see that the expression that we have here for h2 and the expression here that we have for a2 are different. So we can just let them equal. So to make the explanation clearer, I will call this equation 1. I will call this equation 2. Let the equation 1 equal to equation 2. You have 12, 120 sine theta minus 45 is equal to 60 sine square theta. All can divided by 15. All can divided by 15 now. So divided by 15, you have a 4 sine square theta minus the 12 divided by 15, 120 divided by 15, 8 sine theta plus 3 equal to 0. So we try to factorize it. Okay, not correct. We need to make it become 2 here and a 2 here. Then this one, it will be a negative 3 minus 1. Sine theta equal to 3 over 2. And sine theta is equal to half. Okay, this factorization is correct. Then after that, you need to understand that the sine theta cannot be greater than 1. So you ignore this result. Therefore, your theta is 30 degree. That is the value of the theta. They didn't mention radian or degree. Just leave it as 30 degree will do. Then move on. C. Find the speed of P when t is equal to 3. So this is t equal to 3. This is also t equal to 3. So what you need to do is actually just find the horizontal displacement. X is equals to this 40 cos theta. This is a 40 cos theta t. What is a cos theta? The cos theta is a cos 30 degree. So this one, it will be 20 sec 3 t. Then from here, I can get the x dt. The x dt is a 20 sec 3. Okay, this one not so tricky. Then for the vertical displacement, you have a y equal to the 40 sine 30 degree t minus a half g t squared. So over here, you will get this as a 20t minus a 5t squared. Then you find the dy dt. You have a 20 minus a 10t. Then when t is equal to 3, my v is equals to the dx dt squared plus the dy dt squared. So this will be square root of 20 sec 3 square plus the 20 minus the 30 square. Press the calculator. Okay, 100 plus 20 1,300, square root of 1,300. Well, you can actually leave it like this. Okay. Or you can make it become decimal. You can make it become decimal. So the decimal 10 sub 3, 10 sub 13, 36.1 meter per second. That will be the answer for the question number 7. Okay, so done.